Today we're going to go through how Sparrow can handle complex assays, like for instance, combinatorial chemistry. To do that in a reasonable amount of time, we're going to do a small combinatorial workflow here, starting with two 96-well plates, each with a quarter of them full, so 24 wells and 24 wells, and then we're going to combine them, each well with each other corresponding well, from plate 1 to plate 2, so that's 576 unique combinations, and we're going to put those in a 384 well plate and a half. We could just as easily scale that up and be two full 96 well plates. That would take something on the order of 24 384 well plates, about 8 hours to run. So we're not going to do that this time around. We're also not going to go through in detail how we're going to set this up transfer by transfer, step by step. If you'd like to see how we do that block by block, check out the accelerating assay development video that I have up in one of the other links. Let's get started. We've got here source plate A, 24 wells of the 96 filled, and the same true of source B. And then we've got our set of common conditions in a reservoir. This would be, let's say, in a combinatorial reaction, your catalyst, your base, any other types of reagents that you want to add in to every well. We're going to first distribute those common conditions to each well in the 2 384 well plates with this transfer block. And then we're going to do the combinatorial step. In both cases, we're going to use our CSV transfer function to take a plate map which defines all the transfers, first going from one of the source plates. In this case, we're going to take each well, for instance, well A1, and we're going to transfer this liquid in well A1 to 24 wells in the destination plate. So that means that for each of the 24 wells in one of the source well plates, it's going to get a 6x4 rectangle of the same shape as the input in the destination plate. Then what we're going to do with the second transfer is we're going to stamp all of the 6x4 wells in the second plate into each of those 6x4 rectangles that contain the same thing, which is one for each of the wells in source A. If you didn't follow that, that's okay. The core thing to take away is that the two CSVs that we're uploading here are the definitions of a transfer pattern that will give you a combination of every well in source A with every well in source B. So how do we do that? We start by saying that we're going to use a CSV upload block. We're going to upload that CSV file and then map the names, because maybe the CSV file that your LIMS system generated has slightly different names than what you might have put in the Sparrow protocol. In this case, in the CSV I called one of my source plates plate B, and I called it source B in the Sparrow protocol generator. So this is what allows me to map those two together and make sure everybody knows what everyone else is talking about. And then to check my work and make sure everything is what I think it is, I can get a preview here of all of the transfers that are going to happen. And if I want to see everything, I can get that data, and it will be expanded here. And then I'll scroll all the way down to the bottom to get that final piece, the standard liquid handling protocol settings that we get. And I'm going to choose to use 50 microliter tips here because we're pipetting into a 384 well plate. So we need to be a little bit careful there. Much the same happens for the CSV transfer step here. So now I'm going to go to the final step of sending it to the instrument, and let's see it run. I have a Hamilton Microlab Star behind me in my lab. We're going to use that robot, but I could just as easily send it to any robot in my fleet in San Francisco or Boston, or if you have a fleet anywhere on somewhere else in the world, there too, as long as it's plugged into one of our Sparrow control boxes over USB. So I laid out my deck here, but if you have a different deck layout or things change, you can of course move things around appropriately. If you want to see that in depth, check out that earlier video around accelerating assay development. Now we're going to run, so I'm going to say review and run, go through my pre-flight checklist now, making sure that all of my tips are in the right place, that I have the appropriate amount of liquid in each of my reservoirs. I did that right before I ran, so now I'm going to run. Of course, you can see that this protocol is going to be taking quite a bit of time to run to completion. I'm going to cut it a little bit short, but if you ever want to see the full run version, reach out to me and I can spin this up, record the full long version for you. So I'm going to narrate this a little bit, and then we're going to close. The beginning, you can see here, we picked up that rack of 50 microliter tips, and we aspirated liquid from the set of common conditions, and now we're stamping that down first to the 384 wheel plate number 1 and then to 384 wheel plate number 2. You notice that we're actually getting 4 stamps for each of the plates. That's because the 384 wheel plate is 4 times as dense as a 96 well plate. So it stamps it 4 times. It first completed the first plate, and now it's doing the second plate. You saw I needed to hit a kind of refill and resume block. That's a setting that I actually should have probably changed earlier to let it know that it should use the same tip depth across each of them. So don't worry about that. If you want to have that be smooth and not require human intervention, that's totally something that's in the capability set. We have things set up both to enable ease of prototyping, but then also turn on the scale. So when you're ready to run this, you can. You'll see in a future video how we demonstrate our capabilities around automatic air handling along the same regards. So we've completed that now, and we're going to move into our second phase where the first CSV defines how we're going to take liquid from the first source plate and for each well move that liquid into a corresponding rectangle of wells in the destination plate of the same footprint as the second source plate. That's how we do that final stamp to get all of the N by M full combinations. What you're seeing here is that each of the 4 independent channels that are 1 ml, which is how our robot is configured, we have 4 of the independent channels at a larger 5 ml volume that we're not going to use here. Each of them were independently set to drink from the well A1, and then they dispense to the appropriate location elsewhere. So they're doing that right now. And then that's going to continue for a little while. I'm going to let this run for a little bit just to show you what's happening. We may not get to the stamping part where we do the offset pipetting to do the final correspondence in this particular video, just because it's going to be quite a bit of time between now and when that happens. So if you do want to see that, please let me know. Otherwise, it was wonderful creating this demo for you. If you're interested in this for your lab or you're interested in learning more, please reach out. Send me an email at mitch, M-I-T-C-H, @sparrow, SPAERO.bio, or you can click one of the contact us boxes on the website. Thanks so much.